Hello everyone. So in this session, we'll see how do we use those complementary angles formula as well as trigonometric identities. The very first question is write all the trigonometric ratios of angle A in terms of secant A. That means what? If I want to write down sin A, I should express it in terms of secant A. If I want to write cos A, we have to express it in terms of secant A likewise, right? So first one we are focusing on sin A, right? So let us choose the first trigonometric identity, which is sin square A plus cos square A equal to 1. So that can be written as sin square A is equal to 1 minus of cos square A. Again, I can write sin square A is equal to 1 minus. We are interested in converting everything into secant. So cos square A can be written as 1 by secant square A, because secant A is inverse of cos A. So cos A's inverse will be 1 by secant A. Sorry, I can write cos A as 1 by secant A. Since there is a square, I wrote it as secant square A. Now for this, the LCM is secant square A. So here you will have secant square A minus 1, which means sin A is square root of secant square A minus 1 divided by, if I take a square root of secant square A, it will be simply secant A. This is the first conversion or first trigonometric ratio. Then the second one, cos A in terms of secant A. That is direct. It is simply 1 by secant A. Then the third one, it is tan A. We know tan A is sin A divided by cos A. Already we computed sin A in terms of secant A. So I will write that square root of secant square A minus 1 by secant A, and divided by cos A means it is 1 by cos A. I have to multiply. 1 by cos A means it is secant A. So secant A I should multiply. This and this will get cancelled. Ultimately, tan A will be square root of secant square A. Now that we got sine, cos and tan in terms of secant, we can now do the other trigonometric ratios, which are cosecant, secant. Any secant is not required anyway, because we are converting everything into secant. So we'll ignore secant, but we have to do it for cosecant and cotangent. Let us do that. Cosecant of A will be 1 by sin A. Already we computed sin A, which is this square root of secant square A minus 1 by secant A. Now we have to write the inverse. That means it is secant A divided by square root of secant square A minus 1. Is it? Yes. That is 1. Then next is cotangent. It is 1 by tan A. Already we computed for tan A. We'll write the inverse 1 divided by square root of secant square A minus 1. That is what is about this question. Right. Let us move on to the 22nd question. So here we will be using both the complementary angle formula, which is sine of 90 minus A. We know it is cos A. Similarly, cos of 90 minus A, we know it is sin A. So we will apply both for us to evaluate this. So first let me write down sine square 63 as it is. I'm writing this sine square 63 as it is. Then for the second one, I will apply this ratio, this equation. What is that? I will substitute A for 63. If I substitute A for 63, what will happen is 90 minus 63. 90 minus 63 is 27. But here there is a square. So, or let me write it. Let me write it here. So if I substitute A for 63, we have sine 63, I'm sorry, -90 minus 63. It will be 90 minus 63 is 27. This will be cos 63. So I can straight away substitute sine square 27 as cos square 63. Now, this is one part. Similarly here, let me substitute A for 17. What will happen? Cos 90 minus 17 should be equal to sine 17, right? So applying that, first term I will write as it is, cos square 17. Second one, I will substitute. This is actually cos 73. Cos 73, we know it is sine 17. So straight away sine square 17. Now the numerator is also 1, denominator is also 1 by applying the first trigonometric identity. So the final result is also 1 only. Let's move on to 23rd problem. It is very similar to the previous. Again, using sine of 90 minus A is equal to cos A. So if I put it as, what if I put A as 65, then sine of 90 minus 65 will be cos 65. Then if I put A as 25, then sine of 90 minus 25 will become cos of 65, right? So now let us apply all this here. So first one, this is what? This is sine 25. Sine 25, I will substitute it with cos 65. Then cos 65, I will write it as it is. Plus, here, this is what? Sine 65. The first one, I will write it as it is. What is this? This will become something wrong I wrote. Here I should have written 25. Sorry. So that means first one, I will write it as, this is what? This will become sine 65 is equal to cos 25. Here it is sine 25 is equal to cos 65. So that is what we did here. Sine 25 is cos 65 that I wrote. Here I will replace this cos 25 as sine 65. So sine 65, sorry. And then sine 65 again. So the first one is cos square 65. Then second one is sine square 65. This will be ultimately. Let's move on to the next one. To prove this left-hand side cosecant theta minus cot theta, the whole square should be equal to 1 minus cos theta divided by 1 plus cos theta. Okay. Let us start with the left-hand side. LHS is cosecant theta. I can write it as 1 by sine theta minus cot theta. It is nothing but cos theta by sine theta, the whole square. This I will rewrite it as 1 minus cosecant theta, the whole square, by sine square theta. Right. Now, let me keep the numerator as 1 minus cos theta, the whole square, divided by sine square theta can be written as 1 minus of cos square theta. 1 can be written as 1 square also. So what I will do now, I will apply a plus b into a minus b formula. That is, let me write that. A square minus b square is a plus b into a minus b. We will use this algebraic formula here in the denominator. So here a denominator will become 1 plus cos theta into 1 minus cos theta. Now, here we have 1 minus cos theta. Here we have 1 minus cos theta, the whole square. So if I try to cancel, one term will go. So you will land up with 1 minus cos theta divided by 1 plus cos theta. That is the required right-hand side to us. Right? So that is this problem. Let's move on to the next one. Again, it is about proving. Let me start with left-hand side. Let me take LCM in the left-hand side. LCM will become now common LCM, which is cos A multiplied by 1 plus sin A. So that means we'll be doing a cross multiplication, cos A into cos A, it becomes cos square A. Here it will be 1 plus sin A into 1 plus sin A. That means it will be 1 plus sin A, the whole square. Now let's expand it. First one is cos square A plus, now it is like A plus B the whole square, A square plus B square plus 2AB, 2 times sin A divided by cos A into 1 plus sin A. Right. So if we look into this, this and this will lead to 1. So this cos square A plus sin square A is 1. Already there is a 1. That means we'll be adding that 1 plus 1. So it becomes 2 plus 2 times sin A divided by cos A times 1 plus sin A. Now in the numerator 2 is common. Let me take it outside. 1 plus sin A divided by cos A into 1 plus sin A. This will get cancelled with this. So you will have 2 by cos A. What is 2 by cos A? 1 by cos A is secant A. So I can write it as 2 times secant A, which is our right hand side. So hence the proof. So this ends this particular session wherein we had used some of the complementary angle formula as well as the trigonometric identities to solve some of the problems. Again, we'll meet up with similar problems using other trigonometric identities. How do we use by solving some of the problems? Till then, see you all. If you like this contents of the video, I request you to share with others and also subscribe to my channel so that you get your regular updates about the videos what I'm posting in the channel. Thank you.